AI-driven personalized nutrition, rooted in the integration of individual genetics, microbiome composition, and lifestyle data, is on the brink of transforming anti-aging strategies from generic advice into precision interventions tailored to each person's unique biology. This shift represents a profound departure from the traditional "eat this, not that" model, acknowledging that the optimal diet for health and longevity can differ dramatically from one individual to another, depending on factors like gene variants influencing nutrient metabolism or the composition of gut microbes that modulate inflammation and energy balance. Early pilot studies have demonstrated the power of this approach. When AI systems analyze detailed data from a person's genome, blood markers, microbiome sequencing, and even wearable devices tracking sleep and activity, they can generate individualized dietary recommendations that meaningfully improve biomarkers linked to aging. For example, participants receiving AI-personalized diets have shown greater reductions in postprandial glucose spikes compared to standard dietary guidelines, reducing a key driver of metabolic aging, and enhanced gut microbiome diversity, which is associated with lower systemic inflammation and improved immune function. The commercialization of at-home genetic and microbiome tests is rapidly lowering barriers to this technology. Millions of consumers have already had their DNA sequenced, and microbiome testing kits are becoming as commonplace as fitness trackers. In the near future, AI-powered diet coaches will combine these datasets with continuous health monitoring, like glucose or ketone sensors, to generate meal plans that adapt dynamically to changes in weight, stress, or hormonal shifts, offering unparalleled responsiveness to life's fluctuations. Such platforms will go beyond calories and macros, fine-tuning intake of micronutrients, polyphenol, prebiotics, and meal timing to suppress chronic inflammation, optimize mitochondrial efficiency, and support autophagy, hallmarks of aging biology. Moreover, personalized diets will increasingly reflect individual differences in circadian biology, with AI adjusting meal timing recommendations to align with one's genetic chronotype for better metabolic health and sleep quality. For example, an evening chronotype might receive a plan emphasizing nutrient-dense meals later in the day, without the same adverse metabolic effects observed in early chronotypes. While today's personalized nutrition services mostly offer static reports, the future will see continuously learning systems that refine dietary recommendations in real time based on updated biomarker data, wearable feedback, and even mood or cognitive performance metrics logged through apps. AI will identify subtle trends, such as rising inflammation markers or shifts in microbiome profiles, and intervene with meal adjustments before these changes translate into disease risk. Over time, these systems could even integrate data from senescence or epigenetic aging markers to track how dietary tweaks impact biological age, closing the loop between personalized diet and measurable longevity outcomes. However, challenges remain. Data privacy and security will be paramount as individuals share intimate health information with AI platforms. Misinterpretation of complex genetic or microbiome data could lead to misguided dietary advice, underscoring the need for rigorous validation of AI algorithms and clear guidelines for healthcare professionals integrating these recommendations. Social factors, like cultural dietary traditions or economic barriers, must also be addressed to ensure equitable access and meaningful personalization for diverse populations. Nonetheless, the convergence of consumer demand, affordable multiomics testing, and rapid AI advances will make personalized nutrition a cornerstone of future anti-aging strategies. Companies will offer not just meal plans, but subscription-based ecosystems with regular microbiome and blood testing, AI-curated grocery lists, recipe suggestions, and real-time coaching, all aimed at keeping biological aging in check. As clinical evidence accumulates showing that these personalized interventions reduce inflammation, stabilize metabolism, and preserve cognitive function, AI-driven nutrition will shift from a niche offering to a standard recommendation in preventive and longevity medicine. This revolution will empower individuals to take control of their aging trajectory through food, transforming every meal into a targeted, dynamic intervention for extending health span and vitality.